Alright, in today's video, we're going to go through mirrors, focusing on concave, converging, and convex, diverging mirrors. We'll explore their properties, image formation, and applications. Understanding these principles is very crucial and can definitely be applied in many different fields, especially medicine. So let's dive in. Concave mirrors, also known as converging mirrors, have a reflective surface that curves inward. They focus incoming parallel light rays to a single point known as the focal point. Concave mirrors can form both real and virtual images, depending on the position of the object relative to the focal point. So, real images. When the diagram is placed beyond the focal point, the reflected rays converge to form a real, inverted image. This image can be projected on a screen. Virtual images. When the object is placed between the mirror and the focal point, the reflected rays diverge. The extensions of these rays converge behind the mirror, forming a virtual, upright image. So magnification is given by the equation m is equal to negative di over do, where di is the image distance and do is the object distance. The negative sign indicates that real images are inverted. Convex mirrors, also known as diverging mirrors, have a reflective surface that curves outward. They cause parallel light rays to spread out as if they were diverging from a focal point behind the mirror. Convex mirrors always form virtual, upright, and reduced images, regardless of the object's position. This property makes convex mirrors useful for providing a wider field of view, such as in vehicle side mirrors. Understanding concave and convex mirrors is crucial for the MCAT, because these concepts test your knowledge of optics, which is fundamental in physics. Key things to remember include the behavior of light rays with concave and convex mirrors, the formation of real and virtual images, the magnification formula, and its applications. So in medicine, mirrors actually play a significant role in various diagnostic instruments. For example, concave mirrors are used in ophthalmoscopes to examine the retina, while convex mirrors are used in dental mirrors to provide a wide field of view inside the mouth. Understanding the principles of mirrors helps medical professionals use these instruments effectively to diagnose and treat patients. Now, let's challenge your understanding with a couple of difficult MCAT practice questions. An object is placed 10 centimeters in front of a concave mirror with a focal length of 5 centimeters. What is the nature and position of the image formed? A. Real, inverted, and 10 centimeters in front of the mirror. Virtual, upright, and 10 centimeters behind the mirror. C. Real, inverted, and 15 centimeters in front of the mirror. Or D. Virtual, upright, and 15 centimeters behind the mirror. Now, this equation we're going to talk about in a future video, but the equation that you'll want to know is 1 over f, or the focal length, is equal to 1 over do, which is the distance from the object, plus 1 over di, which is the distance from the image. So essentially, we're trying to solve the object's distance, so that's one way we can do it. Or we could first figure out if the image is real and inverted or virtual and upright. So this is a classic example on the MCAT where you are given a 2x2 question. A 2x2 question is essentially two answer choices have the first half the same and the second half different, and the other two have the inverse. The first half has two different answer choices, and the second half has the same answer choice. So as we can see here, A and C are one set, real, inverted, real, inverted. What's different is the 10 centimeters in front of the mirror or the 15 centimeters in front of the mirror. And then same with B and D. Virtual and upright, but being the same one, and then the other side, 10 and 15, being different. What we first can solve for is the image distance, and then from there, given the sign of the actual distance from the image, we'll be able to know whether or not it's in front or behind the mirror. So, going through the equation, we get 1 over 5 is equal to 1 over 10 plus 1 over di. We then can solve for one side. 1 over di is equal to 1 over 5 minus 1 over 10, which gives us 2 over 10 minus 1 over 10, which is equal to 1 over 10. Essentially, we get 1 over 10 is equal to 1 over di, and solving for di, we get 10 centimeters. Since it is positive, we know that the image is real and inverted, and it's located, therefore, 10 centimeters in front of the mirror. So, let's do another question. A convex mirror has a focal length of negative 20 centimeters. An object is placed 30 centimeters in front of the mirror. What is the nature and position of the image formed? A. Virtual, upright, and 12 centimeters behind the mirror. B. Virtual, upright, and 20 centimeters behind the mirror. C. Real, inverted, and 12 centimeters in front of the mirror. Or D. Real, inverted, and 20 centimeters in front of the mirror. So again, in this question, it is another 2 by 2. Again, we are using the mirror equation. So 1 over f is equal to 1 over dO plus 1 over di. And so plugging it in, we have 1 over negative 20 is equal to 1 over 30 plus 1 over di. Solving for di, we can just set up fractions, which we get negative 3 over 60 minus 2 over 60, which gives us negative 5 over 60, or negative 1 over 12. di is then therefore equal to negative 12 centimeters. Since the di is negative, the image is virtual and upright, and therefore located 12 centimeters behind the mirror, given the sign of the image. So to excel on the MCAT and other exams, it's crucial to master the following key points. Concave mirrors can form real or virtual images depending on object placement. Convex mirrors always form virtual, upright, and reduced images. So in summary, understanding concave and convex mirrors is essential for mastering optics concepts on the MCAT. By grasping these principles, you'll be well prepared for the exam and future studies in medicine. And if you found this video helpful, don't forget to like, comment, and subscribe to our channel for more exam prep content. If you're in the app, please make sure to also like the video and comment if you have any questions. Your support helps us to continue to create informative videos to aid in your study journey. Good luck studying.